Okay, so welcome back in again. We're slightly delayed in the program, but that's not a problem at all because it's also lovely and interesting. So my name is Kristina or Kia Höök, and I'm going to chair the next session, and I'm super happy to introduce, first of all, Barry Brown, my dear colleague here in Stockholm. He's working at Stockholm University, and one of the projects we have together is on implicit interaction. And so this whole seminar is very, very interesting to us in that work. So by that, Barry, go ahead.
Great, thank you very much. So the talk I'm going to try and give today is a bit grubby in a way. It's actually about what work we might be able to do in this interface between HCI and AI. It turns out interdisciplinary work is really pretty tricky and very damaging for your career, because even though funding agencies are often emphasize it, you need to have an audience as an academic. And if you're in this borderline between two different disciplines, often you don't have an audience. And in fact, relationships between academic disciplines and even academic sub-disciplines can often be quite fraught. But I don't want to start my talk there. I actually want to start my talk today with this fellow British person here. Do any of you know who this is? Sir Tim Berners-Lee, yeah. Tim Berners-Lee, of course, kind of famous for inventing the World Wide Web, building, of course, on the work of lots of other people, but such wonderful technologies as HTTP and the URL are partly the result of Berners-Lee's work. There's an amusing story when Berners-Lee proposed the web to his manager at CERN at that time. He wrote up a document proposing the web, and he got this comment on it from the manager. Ah, ta-da! Okay, he didn't get that comment. He got... It'd be my fault to have the technology fail. No. I'm going to... He got the comment on this proposal for the World Wide Web saying that it was vague but exciting, which is pretty much what every funding application I've ever submitted has got that comment. Let me try this. Just jump in here. Let's see if this is going to work. Okay. Oh, great. There we go. Cool. So I want to talk about what Berners-Lee did next, because it isn't always the inventors of technology that have the best idea what to do with that technology. When I was a postdoc, about 2001, 2002, Berners-Lee and other people in the hypertext community were pushing this idea here, the semantic web. And the idea was that rather than websites being human readable, they should actually be tagged up with pre-decided taxonomies so that they could be machine readable. And the idea was that web pages would be written as much for other machines as they would be for humans to read. It was called the semantic web, and it was really quite a big thing. About that time, I had the pleasure of visiting Yahoo. And when I was at Yahoo, I met a guy called Cameron Marlowe. Cameron Marlowe went on to run data science at Facebook, but when he was there, he was working on new web technologies. And he showed me this thing here, which was an address book for Yahoo, and it had quite a simple thing in it. Anyone could edit it, but also you could tag people at Yahoo with their skills. So he showed me that a bunch of people had tagged Cameron as being good at PHP, and so everyone could search, and if they wanted an expert in PHP, they could find him. I didn't realize it at the time, I wasn't clever enough, but that was actually the future of the web, not the semantic web. That was one of the first Web 2.0 systems, one of the first systems that was built around user-generated content, and you can see those ideas in systems like LinkedIn, perhaps without the harassing emails, but also in the social web, social media, and the like. The idea that the web wasn't about being machine-readable, but about being social. And this brings us, I think, to this point here. Artificial intelligence has just made such great advances and is burning so very, very bright right now. I'd heard that there was over 4,000 submissions to the NIPS conference, one of the big machine learning conferences, really kind of burning so bright. But I think it isn't always those who invent the technology that have the best idea about what its eventual use and application will be. Oh. I'm going to go through the slides like this. Let me see if this works. Right, great. So I think there's three possibilities for this relationship between AI and HCI. And like I say, I'm going to be a bit grubby, because what I'm going to talk about is what I think are the three bits of work that we can get. We already started on, and the three types of work that we can do in this borderland. I'm going to talk about adversarial work. I'm going to talk about service work. And lastly, I'm going to talk about domain work. But let me start with adversarial, because I mentioned that disciplines are often have unfriendly relations with each other, and there's often conflict between disciplines. Sometimes disciplines even try and take over each other. Economics is quite famous for this. And I think there is likely to be a lot of conflict between HCI and AI. About 10 years ago, Jonathan Gruden wrote this really nice piece called AI and HCI, Two Fields Divided by a Common Focus. And what he argued was that essentially AI and HCI are actually looking at the same thing, the automation of human action. But they've got such different perspectives on what needs to be done and what's important that they're sort of incommensurable with each other, and they're going to be in conflict. And he suggested that just as there's AI winters and summers, similarly, there would be alternate winters and summers for HCI as different ideas came in and out of favor. And he suggested that essentially when AI was up, HCI was down, and vice versa. Of course, we can see now he had this line going up at the end there, but of course we kind of can know where that's gone. This was very controversial. Jonathan told me that when he submitted the paper, he had Donald Norman phone him up and say that he couldn't publish the piece. It was very controversial. And it was very controversial because it wasn't saying that the problem was the ideas or that it was intellectual issues here. It was actually saying it was a fight over funding, money, resources. It was really quite grubby in some ways. But of course there is a bit of truth to it, isn't there? And I think the adversarial relationship between HCI and AI is actually going to be one of the most productive, at least for HCI in the next few years. Two books you might have come across, Weapons of Math Destruction by Cathy O'Neill, but also Automating Inequality by Virginia Eubanks. And these are two books that I think that are spearheading the critical examination of the role of AI in society. Because as we said in the introduction to this colloquium, the point of AI ultimately isn't going to be how elegant its models are, but the impact that it has on welfare recipients who are having their eligibility decided by algorithms, or even universities who are having their ranking decided by big data resources. Specifically in HCI, I think there's this kind of growing concern really for the kind of impacts that the systems we're designing are having on the world. This is some work looking at how racial inequalities and the wait time for Ubers correspond. So this is a map of Chicago, and in the south of Chicago, which is a traditionally African-American area, you're going to be waiting a lot longer for an Uber. You aren't even going to be able to get an Uber at all. And even something as benign as nature photography can show similarly these kind of worrying outcomes from systems which were thought to be relatively neutral. This is some recent work looking at the recommending of photographs on Instagram. So essentially what this shows this work shows is that men tend to favorite or like photographs by men more than women tend to like or favorite photographs by women. Men are more prejudiced than women are, even just about how they like nature photography. With a recommendation algorithm, going on top of that, a social navigation algorithm, using those likes and using that to recommend content, they argue that this, and they show that what it ends up doing is creating a glass ceiling, an algorithmic glass ceiling, where more men rise to the top of people's recommended Instagram feeds than women do. So what can seem quite a benign algorithm, just recommending you nice pictures based on what you like, can end up having this prejudicial outcome. This doesn't happen in a vacuum, of course, as well. And CHI, perhaps, HCI, more than perhaps any other part of computer science, is very much embedded in particular political movements. And we're in an also political time, particularly in America. I mean, I think it's sometimes said that a reaction causes an equal and opposite reaction, and sometimes extremism on one side can lead to extremism on the other. But for whatever reason, it's clear that this is one of those times where, as it was asked 50 years ago, even in an academic computer science area, you can be asked, well, whose side are you on? Politics is not divorced, unfortunately, from the work that we're doing. If you had the pleasure to go to CHI a couple of months ago in Canada, you might have seen this keynote. Christian Rudders, he was the guy who founded OkCupid. He did a keynote where he talked about all the data that's on the that he collected from the OkCupid website, and he showed some things like, for example, men rate women different than women rate men, and showed some of the sort of differences in how people are rating people and answering to people online. Maybe 5 years ago, I think his talk would have went down better, but it caused a little bit of kind of ruckus at the conference, partly because we are also worried about the masculine nature of computer science. It's just so male-dominated as a field that we are worried about that it's distorting the work that we're doing. And this perhaps slightly bro style of presenting, I think might have gone down well, but after things like Gamergate, people are much, much more sensitive. And indeed, some of the response to the keynote, well, I've never seen such a successful keynote in some ways. Jeff Bingham said it was a dumper fire. The chairs had to actually apologize for inviting that person to do the keynote. I don't actually want to get into the details of that keynote or not, but the important point to make is this is a political time and people are highly sensitive. And I think with some good reason, because we have to be more and more worried about the impacts the systems we're building are having on the world. And for many years, CHI has maintained a kind of political neutrality. I've been on review committees where we've actually excluded work because it was considered to be too political. And that's come back to bite us. The political impacts of social media being one thing, a whole host of other questions, indeed actual research in our field showing the potentially prejudicial outcomes of our systems. I think, Suzanne talked about different waves in HCI. I wonder if we're coming upon a more political wave in HCI where there's going to be more critical reflection on the kind of work we're doing. This is a kind of Oppenheimer moment where we're really starting to worry seriously about these algorithmic systems that we're making and designing. Okay, service. By this I mean when the algorithms and techniques that are used in AI can be applied to HCI problems and vice versa. This is, I think, the field that intelligent user interfaces has really pioneered. They've made great use of techniques developed within machine learning and AI. And unfortunately, as a field, they kind of started off with a great failure, which was the Microsoft Clippy Office Assistant. Clippy, of course, would tell you at the wrong time you were writing a letter, and it would interrupt what you were doing, and was kind of a bit of a kind of disaster. But as often with technical projects, the first go doesn't work, but then the second one does. If you use a Mac computer and you type on your Mac computer, there is an algorithm that is going in and correcting your typing as you're doing it. it gets turned on in the latest OS release, to the point where you might not actually notice anymore that your typing is getting corrected. If you don't believe me, go into the settings and turn it off. You'll be shocked how much of your typing it's correcting behind the scenes, and you're not even noticing. So clearly, I think the IUI community has had great successes in particular specific cases. And this is by taking techniques from AI and applying them to HCI problems. I think there's some kind of more, some other innovative work happening. This is one of my favorite papers, and if you know me, you'll know why. This was a system to help alcoholic young adults, and it would do it through just simply the GPS and the gyroscope on your phone. It could predict when you were going to have a heavy drinking binge, and then you could have some sort of medical intervention. Maybe your sponsor could phone you up, or it could simply just, I don't know, ring and say, stop drinking. And I think this is really nice work because it makes use of, applies AI techniques, I think in a kind of an area where you can really see a noticeable effect. And they managed to show noticeable decreases in drinking behavior by these young adults through this intervention just on their phone. And this is just coming from the GPS and the gyroscope on the phone. It goes both ways. The Recusys community, which is kind of part of AI, if you will, if you were to dice it up, took a bunch of findings that came out of HCI around recommendation, social navigation, and the like, and have formed their own community, I think doing a lot of really interesting work looking at the recommendation of content. So this kind of service relationship can go both ways. But it isn't perhaps the deepest of relationships. And if you actually look at how Recusys people think about humans, I think it's actually a little bit disappointing. This was the human interaction track at their latest conference, and really, I actually don't think they've got such a good understanding of what recommending content is, and that I think will cause you some problems. Okay. Lastly, domain. And by this I mean the ability of HCI to understand the sort of domains that the AI systems will be deployed on, and trying to sort of propagate that back into how you actually, how those systems are designed and built. And Karen was talking about autonomous vehicles earlier. I want to start with chatting a little bit about this use case, because clearly this has been one of the most hyped areas where AI is likely to be applied. I think there's, of course, huge possibilities there. And this is a story, you might not have seen this. This was a Mobileye, which is one of the kind of leading self-driving car companies. This was a car that they were testing in Jerusalem, and under autonomous control, the car went streaming through a red light. Okay, misfortunate, but these things are being tested. Unfortunately for Mobileye, there was a television documentary crew in the car at the time making a documentary about the safety of self-driving cars. And it's a bit unfair to Mobileye, actually, because they're, I think, one of the companies that is taking the most responsible view of this technology. Other companies have been, I think, a little bit less responsible in how they've deployed these systems. And tragically, that's resulted in the case of a number of people dying when their autopilot on their Tesla cars has crashed their car for them. Now, what are we to think of this? Now, Elon Musk, when there was the first fatality with autopilot, sort of treated it as a kind of Bayesian problem. Well, look, actually, if you look at the numbers, autopilot, when it's been activated, is causing less crashes per mile compared to humans driving. I mean, actually, the numbers he's got here are actually plain wrong. Autopilot is actually less safe than a human driving a car, at least on a US road. But I think what Musk is missing is that when you have autonomous cars, it's not just going to be a one-shot thing. People are going to react in their own ways afterwards to what happens. When we have self-driving cars, we have to worry about the second level and third level effects. Are people going to start falling asleep and not monitoring their car while it's being driven? These effects could mean that we could end up actually with more accidents rather than less with autonomous vehicles. In sociology, we call this the law of unintended consequences. It goes back to Robert Merton from the 1930s. It's kind of it's not a huge surprise and very well known, but he pointed out that when you make any prediction in a system about the future state of that system, that prediction becomes, in turn, an element in that system that changes what happens. And this is why algorithms can't predict the stock market, because once they predict the stock market and you start trading using the prediction, well, there's money to be made betting against your algorithm, isn't there? When you make a prediction, it's not this kind of one-shot thing. We have these unintended consequences, and it's the unintended consequences that can really bite you. I like this example. This is from a website called Jalopnik, and it said, well, if we have autonomous cars that can't crash, maybe people will start pranking them. So this was a case here where maybe you could herd a car by standing around it and just moving it along, and it would try and avoid a collision. Or maybe even auto sumo, where you would get two cars together and you would like push them from behind to try and get these cars to fight with each other. And these are silly examples, but I have heard that on Highway 1 in California, there's so many Tesla cars on autopilot that drivers have started to take advantage of the autopilot because they know it'll break if they cut into it. These law of unintended consequences that you put the system out there, and then different things happen. Even auto sumo. I think more broadly, and the kind of point I want to make, though, is that there's knowledge that we have to integrate into machine learning systems that comes from outside training sets. And there's different ways of doing it. There's this kind of trendy technique called differentiable programming, which is where you actually take kind of standard computer science algorithms or data structures and integrate them into your net in some way. So this is actually how AlphaGo 0 made its advances. It had a Monte Carlo kind of module as part of its neural net, and that was what made it so successful in playing the game of Go. But I think more broadly, what I'm interested in is there knowledge from domains, ways of acting, or even just kind of domain knowledge that can be brought into these systems in ways that aren't just simply affecting the training sets. So one of the things I do is I do a lot of work looking at driving behavior, and this is some recent work. I've been trying to look at cross-cultural driving behavior. This is some data from India and Spain and you know where this is, won't you? This is Paris. Trying to compare driving in these different places and try and understand how autonomous driving systems would need to drive differently in different countries. The reason why we have, this is people driving around the Champs-Élysées in Paris, is this is the one sort of Parisian driving that's most like Indian driving, because there's a lot of different road users, and there's a kind of different driving techniques which drivers use there. And I guess our broad interest is in kind of taking lessons from understanding how drivers drive and communicate with each other, and use that for the design of systems. Okay, so there's these three possibilities. I know there's many other ways in which HCI and AI might work together, but I kind of think these are the three kind of strategies that I think are most likely to be promising. So adversarial, where there's a kind of critical response, and HCI sees its role is to essentially be a critical edge in computer science on AI. A service role, which might not be necessarily close, but it's more the kind of transfer of techniques and problem domains between the two. And then perhaps this possibility of a slightly deeper relationship around domain, where we try and draw lessons from the different domains which systems will be deployed in. Of course, you might be asking, is this a meaningful relationship? Well, academic relationships perhaps aren't the most harmonious of ones. And actually often they're particularly interdisciplinary ones are ones with lots of conflict. But perhaps the important thing for academic work is not harmony, but that we still have something left to say to each other. Thank you very much.
Thank you so much. The one point I'm sort of still stuck in the talk is sort of the law of unintended consequences. And I think it's one of those things which is really, really hard to grasp in a way when we think about very dynamic systems. And I put it back, sort of, I have done work in context-aware systems. And basically you have two sort of intelligent systems that try to sort of match each other, and it's never going to work. And this is even on very simple things. It's really hard sort of to getting stability, and I think it's a classic problem of control theory, what we had first. And so is there sort of really sort of the very fundamental question, given that we know that there is this law of unintended consequences, is there a real hope that the whole idea of automating really complex things like driving, like everyday life things, is working at all? Because I think it comes back to the other question from earlier this morning. Once we get a technology, we get new ideas, how we use it. So is there a chance that we get things really to work?
I think one of the best example domains, and the one that's most advanced, is aviation. And the safety people, I guess, everybody should read Perot's Normal Accidents if you want to know anything about this area. But I think aviation is the one that I think is the most interesting area, because they've had autopilots for planes for quite some time. Now, it turns out planes are safer in aggregate because of that. But this second level kind of effect is that you get this skill atrophy, where pilots then kind of like, as I think Akia said earlier, you kind of forget to fly their plane. Even in that situation where you've got highly professional pilots, it's proved to be a struggle. But on balance, still, planes are safer with autopilot on them. And there's been interesting work on, so for example, with landing planes, you can either have a plane land itself, or you can have this system where it guides you through, it puts a box and you have to stay in the box, and you have to land the plane yourself. So there's a form of modified human control where the human's still in control, but assisted by the system, which kind of gives you this landing box, which kind of narrows as you go down to land. And that's proven not only most preferable by pilots, but safer than actually just putting the plane completely onto autopilot for landing. Because it turns out, again, it's like there's so many things going on with landing that so many other things come in and stop it being effective.
Just one response, I think we see this a lot, that people refer to planes, to professional doing professional jobs. And there was this year even at CHI a workshop on what can we learn from this. And I think my takeaway from this is this domain is so different. If we basically will build cars that way, we will not have the next 100 years cars. If you look at certification processes, and I think they need them, otherwise it's not going to work. We are not going to see self-driving stuff in our lifetime. And Philippe Halong, he's working a lot with Airbus, and he was on that workshop. He's very clear. If we want to have the same level, it's not happening in our lifetime.
Yeah, interesting. If you look at the numbers for the disengagements for the Google car or the Waymo car, which is the most advanced one, they actually made like a 2% improvement from this year to last. Now, there's some question about whether they're reporting this truthfully or not, but I wonder if this advance rate's actually started to slow down, but anyway, so. Yeah.
So we have space for one more question while Antti is setting up his computer. Haibo?
Thank you, very nice talk. So actually, what do you really mean meaningful relationship? What do you mean the meaningful? Is to the human or to the computer? If something is meaningful for the human, probably doesn't mean anything to the computer. So I don't know. So what's?
Okay, I mean meaningful between researchers.